All right, we are continuing our notes for section 6.6. Yesterday, you guys focused on adding, subtracting, multiplying, and dividing functions, and focusing on also finding the domain of your answer. When we find the domain for either adding, subtracting, multiplying, or dividing, we look for domain issues for either of our two original functions and anything that might pop up in our final answer. That's going to be a little different today when we start talking about compositions of functions. Okay? It says the diagram shows what happens when you apply one function g of x after another function. So this is where we're actually putting a function into another function. We start out with the inputs of x, or the domain of x. We dump them into our function f. All right, and what we get out is the range. Okay, that's our first function. Then we take all of those answers that we got out and we dump them in as the input for our second function. Okay? When I ask you to take, say, f of negative 2, what does it mean? Yeah, any x that's in function f gets replaced with a negative 2. Yes? So if I said find f of 5, you would replace all the x's with a 5. If I say find f of star, you're going to replace all the x's with a star. Okay? That's what that means. So now what we're going to do today is we're going to find f of g. We are going to take whatever function we have for g and we're going to substitute it inside function f. Okay? That's a composition of functions. The notation that you're going to see, we might see that, okay? It is read g of f. It's a little open circle, not to be confused with the multiplication sign that you had yesterday. It was a solid dot, okay? They might show it like this, okay? G of f of x. Again, that is just telling me we have function f that's using x as a variable, and we have function g that's also using that. Okay. This notation I like better because it's more obvious which function is getting plugged inside the other one. Okay? But both notations you need to understand and be able to work with. The domain of your composition, g of f, consists of x values in the domain of f for which f of x is now in the domain of g. What that means for when we actually do a composition. We are going to look at any domain restrictions on the inside function and any domain restrictions that come across when we do the composition, our final answer. Okay? So if I am looking at g of f of x, I have to worry about domain issues for that inside function, and then I'm going to look at my final answer and see if there's anything else that pops up. Okay? Function composition is not commutative. So f of g and g of f do not necessarily give you the same thing. Okay, so you do have to watch the order. There are two ways to do this first question. It says let f of x equal x minus 5 and g of x being x squared. First of all, are there any domain restrictions on either f or g? Remember from yesterday, we're looking for denominators that can't be 0 and square roots that we can't have negatives underneath. Okay? We don't have any domain restrictions right now. It's asking me to find g of f of negative 3. When we do g of f of x, we still are going to have some kind of function with x's in it. This is saying we actually know what we want x to be. Okay? So there's two ways to go about it. My preference is for you to pretend that you didn't know it was supposed to be a negative 3 until the end. Okay? Go ahead and do the composition of the two functions without knowing that x is negative 3. When you get your final answer, you can substitute that in. But I will show you both ways. For the first one, we are doing g of f. Okay? So that means function f is getting dumped inside of function g. So when I go to write this out, what I want you to do is the first letter you see here is G. You're going to start with G. Wherever there's an x in function G, you are going to just put parentheses. So function G is saying, I'm going to square something. Okay? Now, what we want to square is function f. So we are going to dump f now inside function G and simplify that. Okay? What do we get when we square that? Okay? Squaring a binomial, remember the pattern? Square the first, twice the product, square the last. Now we can find g of f of x. Okay? Or g of f, negative 3. We know our function, our composition, is x squared minus 10x plus 25, and they are telling me now that I want to substitute in a negative 3. Okay? What is negative 3 squared?
9.
Okay? Negative 10 times negative 3. Okay? What do we get? 64 for a final answer? Okay? So, if I didn't tell you what x was, okay, if I just asked for this composition, you are just going to get a different function. Okay? If I give you a specific x value to use, you can actually get a single answer. Okay? Now, if we went back, I said I would show you the other option. This notation says we are going to put negative 3 into function f. We're going to figure out what that answer is, and then we're going to put that answer into function g. Okay? Well, what do we get if we put a negative 3 into function f? We get negative 8. And now if we dump negative 8 into function g, we get 64. Okay? The reason I'm suggesting you practice the first method is that we don't always give you a number. Most of the time we just say find g of f of x or find f of g of x and leave it as an x. So you have to know that pattern. Okay? All right. This one is asking for what? F of g. The last question we just did was g of f. And remember I said the compositions are not commutative. All right, we're going to get a different thing out. Okay? So, what was function f again? What was it, x minus 5? And g of x was an x squared. So this time we are taking f of g. So we are going to write function f down. Wherever there was an x, we're going to put parentheses. So function f is taking something and subtracting 5. Okay? What we want to dump into it is function g. So my solution here would just be x squared minus 5. All right, different answer than what we got on the previous one. Now, what is f of g of negative 3? If we put a negative 3 in there, we're going to square it and then subtract 5. We get what? Okay? All right. There were no domain restrictions on either of these, correct? Nothing on f, nothing on g, and nothing in the final answer that we ended up with. Okay? For the next ones, we are going to identify our domain as well as do a composition. Okay? This one is saying find f of g. So which function are we going to start writing? We're going to start writing f, right? The very first thing you see is an f. we're going to start writing function f. Wherever there is an x, we are going to leave a hole. Okay? So function f says we're taking something, we're squaring it, and subtracting 4. So something is getting squared, and then we're going to subtract 4. What is it that we want to square? All right, so we're going to dump that g of x inside there. X plus 7 gets squared into what? All right, x squared plus 14x plus 49, and then we're subtracting 4. So we end up with x squared plus 14x plus 45. Okay. Did they give you an x value to plug in? No. So that's my answer. Okay. Now, for the domain, we look at any restrictions on the function that we were dumping in. Okay. We dumped in an x plus 7. Are there any domain restrictions on that? No. There's no denominators here. There's no square roots here. Then we look at our final answer. Any domain restrictions on that? Okay. So my domain here would be all reals. Okay. All right. This one, we are given f of x being the square root of x minus 3. G of x is the function x plus 2. They are asking me to find g of f and also figure out the domain. All right. So g of f. Which function do I start with? I'm going to start with g. I'm going to write it out wherever there's an x. I'm going to put a parenthesis. So my function g is something plus 2. So something plus 2. What am I dumping in? Okay. Now, is there anything I can do to simplify this? No. So that's my answer. The square root of x minus 3 plus a 2. We could talk about the graph of that. Yes, we know the transformation. It's a square root graph that's been moved where? Right, 3 and up 2. Okay. It's asking for the domain. So I look at what I have dumped in. Are there domain restrictions on the square root of x minus 3? Yes. So let's look at what they are. X minus 3, since it's underneath the square root symbol, cannot be negative. It has to be 0 or higher, which means x is going to have to be greater than or equal to 3. Yes? We talked about the transformation of this. We said it's a square root graph that normally looks like this, right? But we've moved it right 3 and up 2. So we've done that to it. So does it make sense that we're saying the domain has to be 3 and higher? Okay. Are there any different domain restrictions on our final answer on this whole thing? Okay. So my domain for the composition, x has to be greater than or equal to 3. All right. We have one more like that, and then we will do one application question. This one says let f of x be x plus 4 and g of x be x squared plus 5x plus 3. It says what is g of f of x? So which function are we starting with? Okay. So we are going to take this g function here that's x squared plus 5x plus 3. Wherever there's an x, we are going to leave a hole. Okay. And what is it that we are dumping into that? So it's going to go into both of those holes? Okay. Are there any domain restrictions on the piece that we just dumped in? No. Okay. I'm going to go ahead and pause the recording. I want you guys to try simplifying this one. All right, let's check your work. X plus 4 quantity squared should give you x squared plus 8x plus 16. Multiplying the 5 to the x plus 4, we get 5x plus 20, and then we're adding 3 to that. So combining like terms, you should have x squared plus 13x plus 39. Agree? Okay. Any domain restrictions on that final answer? We didn't have any on the inside function. We don't have any showing up in our final composition. So my domain is all reals. Okay. Our last question. It says, we have a coupon good for $5 off the price of any large pizza. We can also get a 10% discount on any pizza if we show the student ID. How much more would you pay for a large pizza if the cashier applies the coupon first? So there are two options here. We have a discount and we have a coupon. Depending on the order that you apply them in, you're going to have a different price that you have to pay. So we have to look at both options to see what that difference is. So we are going to define C of x will be our coupon function. What is the coupon doing for us? Okay, so she said subtracting 5 from the total. So whatever my original price is, I get to take $5 off of it. Okay? So in this case, we're saying x is the price of a large pizza, the original price. All right. What does the discount do for me? Okay, so when they give you a percent off, that's a percent of the original price, correct? So this is saying take your original price and subtract 10% of that price. Well, if our original price is the 100% of it, we're taking away 10%. What we have left here is just the 90% of the original price. Does that make sense? Okay. So now we have to do two different compositions. If we do the coupon first, that means we are going to take our original price, we are going to apply the coupon to that. Okay? Then we're going to take that total and apply the discount to that. Okay? If we do the discount first, we are saying take the discount off your original price, and then whatever that bill is, apply the coupon to that. Okay? So we need to do both of these compositions. The first one, I'm going to start by writing my D function, which was 0.9 times something. And what I'm dumping into it is my C function, x minus 5. What do we get when we simplify that? 4.5? Okay. For the second one, we said start with the C function here, something minus 5. This time we're dumping the D function into that. And there's really nothing to simplify. We're getting 0.9x minus 5. So in both cases, we're going to take our original amount and times it by 0.9, right? We're going to pay 90% of it. But in this one, we get to deduct a $4.50 charge. On this one, we get to deduct $5. So what's the better deal? the discount first, right? We get to save an extra 50 cents. Okay? So if they apply the coupon first, which is what they asked, it says how much more would we pay if we apply the coupon first? We're going to pay an extra 50 cents. Right? We only get to take off $4.50 instead of all the $5. Okay? So, as a customer, you'd like to do the discount first. As the owner of the store, they're going to want to do the coupon first. Okay? Questions on any of that? All right, so we looked at adding, subtracting, multiplying, and dividing yesterday. We looked at compositions today. This will be your assignment.